Hello, my beautiful people. We're going to talk about the electron configuration for certain elements. Now, one thing you have to understand about, electron configuration is that everything in the periodic table is separated into blocks. Alright? And these first two right here, group 1 and group 2, and helium. These two, these are in the what is known as the S block. Now, the S block can hold up to 2 electrons in its energy level. And because of it, the S block is usually the first to get filled when you reach a new energy level. So another one is the P block. Let me do this in a different color. There we go. The P block is right here. Right there. Okay, that is the P block. It can hold up to 6 electrons in its energy level. And another one is the D block right here. Right here. Between 3 and 12, these are your transition metals. And this is the D block. See if I can, there we go. Alright, and your next block is this is your F block. It's your lanthanoids and your actinoids. Right here. That's F. Yeah. So, knowing this, now we can start to understand how to configure electrons, which pretty much electron configuration is pretty much just the most likely place that an electron is going to be based on the amount of shells it has and the electrons in those shells. So let's see what's color I haven't used. Green. Alright, so let's say we're trying to find, let's go kind of small for right now. Let's go beryllium. Okay, beryllium, right here, is an element, and this said element has 2 energy levels, which means so how to configure this is pretty much, here's period 1, here's period 2. Okay, period 1 is going to be your first number. And then, seeing as how it's in the S block, we're going to put an S right there. And since it fills that up, we're going to put a superscript 2 right there. And now the next part, this is period 2, so 2 would be the first number. It's still in the S block, so you would have S right there. And once again, subshell, so superscript 2. Now, it may be called a jump, but I don't really see any reason to hold it off. We're going to try to find molybdenum. Molybdenum, right there, number 42. So what I did before is something called longhand notation. Alright, that's when you include all of the energy levels that the electrons pass through. But now I'm going to teach shorthand. So what you do is you go back to its closest noble gas, which is right here, krypton, and you just put krypton in brackets. So I'm going to put, molybdenum right here. And just Krypton. It's Krypton, not Xenon. Krypton. Right there. Krypton. And then I just go through normally. So, once again, we have our S level here, our S subshell. And let's see, this is the 5th period. So 5 is going to be put there, and we fill up that subshell. Now, something to note about the D and the F block, the D block is actually, even though this is the 4th period, it starts with 3. It's because the energy level is not completely filled until it gets to D. So your 3rd energy level of your atom is going to be filled once you hit D. Once you hit the D block. And the F block, even though it starts at the 6th period, is actually going to start with 4, once again for the same reason. So to find molybdenum, like I said, we have our krypton, we have our 5s2, so the next one would be 4, even though it's at period 5, it's 4, so we would put 4 there, and now we're in the D block, so we're going to put a D, and 1, 2, 3, 4, right there, a superscript 4. And that's just the basics of understanding electron configuration. That is bare bones what you need to know in order to do this. Thanks for watching, and I'll see you next time.